Hi, my name's Dr. Emily Burke. I'm the Director of Curriculum at Biotech Primer. Today I'm going to talk to you a little bit about genetically modified apples. I slice a red delicious apple and put it in the lunch for my kids. By the time they open the sandwich bag filled with this all-American healthy snack, the apple has a distinctly un-apple-ish brown coloration. Personally, I would have told you that the scientific community would never get around to solving this problem. But I would have been wrong. Coming soon to a supermarket near you, apples that have been genetically modified to resist browning. Dubbed Arctic apples, the plants were approved 2 years ago by the USDA and have begun showing up on supermarket shelves. Developed by Okanagan Specialty Fruits, the Arctic apple represents a new type of genetically altered food. Typically, genetic modification of plants directly benefits the farmer with increased crop yield or reduced use of pesticides. In contrast, this modification was engineered specifically to please the consumer. Let's take a look at what causes apple browning, how science is able to produce a remedy, and preview what's on the horizon for consumer-oriented, genetically modified food. The browning observed in conventional apples is the end result of an oxidation reaction. Typically, oxidation reactions result in a color change. Think rusting car or the oxidation of metal. In apples, browning is the oxidation of a phenolic compound produced by an enzyme called polyphenol oxidase, or PPO. In order for oxidation to occur, PPO has to come into contact with the phenolic compounds. Within the apple cells, phenolic compounds are typically sequestered inside of membrane-bound compartments. If the cell is disrupted by slicing or dropping the apple, the seal of these compartments is broken and the phenolic compounds are exposed. PPO is then able to act, oxidizing the compounds to create browning. Scientists at Okanagan Specialty Fruits chose to tackle apple browning by blocking the production of the PPO enzyme. No enzyme, no chemical reaction, no browning. They used a gene silencing technique known as RNA interference, or RNAi, to block the production of PPO. Why go to all this trouble just to make apples less brown? This modification is expected to benefit growers, packers, shippers, and retailers by limiting the amount of bruising and other visual imperfections in their apples, meaning less waste and more product to sell. Food processors, likewise, will be able to produce more consistent juices, sauces, and sliced apple products without relying on antioxidant treatments currently in use. The first two varieties of modified Arctic apples are appearing on the market are Golden Delicious and Granny Smith. If successful, they could pave the way for consumer-oriented products such as non-browning cherries and pears. To learn more about RNA interference and a USDA-approved genetically modified potato, read the full article on weekly.biotechprimer.com. Thanks for watching.